Let's get started. Watch this.
Señoras y señores, muy buenas tardes. La Universidad Técnica Particular de Loja y su Parque Científico y Tecnológico les dan la más cordial bienvenida al webinar del día de hoy con el tema Use and Access of the International Space Station to Promote Research and Productivity in Ecuador. Es un honor contar con su presencia en este encuentro virtual. Gracias a todas las personas que nos siguen a través de la transmisión en vivo de este importante evento en nuestras redes sociales, @UTPL-eventos y @UTPL.loja. Su presencia es muy valiosa para todos nosotros. El Parque Científico y Tecnológico de la Universidad Técnica Particular de Loja, junto con Levida Space Industries, LLC, a fin de fortalecer el lazo de colaboración universidad-empresa y generar soluciones basadas en innovación, promueve el webinar denominado Uso y Acceso a Estaciones Espaciales para promover la investigación y la productividad en Ecuador, donde se abordará sobre las oportunidades y herramientas de la industria espacial para mejorar la competitividad de 11 sectores priorizados. Antes de iniciar, me permito indicarles la modalidad de este webinar. Iniciaremos con la exposición de nuestras dos ponencias y al final daremos paso a la ronda de preguntas. Por ello, los invito a dejarnos todas sus dudas e inquietudes en la caja de comentarios. Nuestros ponentes al final estarán respondiendo con gusto cada una de ellas. Para dar inicio, entonces, me permito presentar a Robert Elliott, fundador de Levida Space Industries, quien será el moderador de este evento. Estimado Robert, muy buenas tardes y bienvenido.
Thank you, Gabriela, very much. It's very glad to be here. Today I have the honor to present our two speakers. Molly Mulligan, she's the Director of Commercialization Strategies for Space Commerce Matters. She has served as in the International Space Station U.S. National Laboratory, and she has a wide experience working in companies as Space Pharma in Israel. And her education, she has a PhD from University of Massachusetts in Amherst, and also Smith College. And we also want to introduce Dr. Heath Mills, Chief Scientific Officer of Rhodium Scientific LLC, and he has a wide experience in science-related matters in space through his career. In his education, he got a bachelor's degree from Duke University and also from Georgia Institute of Technology, where he did his PhD in the field of biology. And we're very glad to have them on board to be talking about this very important subject. And we were going to start with Molly. Molly, we're very eager to hear from you and for you to share how we can definitely benefit Ecuador and its local industries with access to the International Space Station for research. Thank you.
Thank you, Robert, and thank you, Gabriela, for this opportunity. I'm very excited. So here we go. Hopefully everything goes smoothly and everyone can see my screen at the moment. So I'm going to talk today about how space can help Ecuador's largest industries. There we go. So why space? Why do we go to space? Well, I always like to say it's to save our planet and save our species. We've always had the desire to explore as humans. We've always gone and tried to explore new places, which is one benefit of being a human and one reason we go to space. But we're also using space to help us as people. And how do we do that? Well, space exploration, as I said, is important for our civilization. It leads to innovation that helps people on Earth. Insulin pumps, Pumps, scratch-resistant lenses on our eyeglasses, laser eye surgery are all things that we have in our everyday lives that have come out of innovation from space exploration. Tempur-Pedic mattresses are another big one that people tend to know. But there's also a lot of research done in space, not for exploration, but to benefit people on Earth. We look a lot at crop science. How do plants and microbes interact? Something they do every day and here on Earth in space. What happens to diseases and pests that bother and infect plants in space? What are their stress responses? Because plants, of course, are going to change how they behave in space compared to Earth. Research also helps us with a lot of sustainability programs focused on climate change, trying to remove plastics from the ocean, looking at water scarcity and drought, sustainable crop production, and energy conservation. We can also use that vantage point of where the International Space Station is, 380 kilometers over our head, for remote sensing and satellite technology. So we can look at weather monitoring, agricultural monitoring, and even looking at plant monitoring. It's a really great resource. But what's so unique about space? Well, one, every day our lives are driven by gravity. Whatever we drop falls to the ground. When you drop something in space, because it's microgravity, it doesn't fall to the ground anymore. You're removing convection, buoyancy, and sedimentation. Outside of the ISS, there's the extreme conditions of space, vacuum, atomic oxygen, and an extreme temperature change every 90 minutes. And then there's the vantage point, 380 kilometers over our head, being able to gather large data sets of the Earth, because every 3 days the ISS covers about 90% of the populated Earth space, if you will. All right, but what does all this mean? We can talk about microgravity, extreme condition, and vantage points. Well, microgravity, again, our lives are dominated by gravity. So when we go to space, it influences everything from the behavior of cells to the health of organisms and microorganisms to fluid physics to how a flame burns and many other processes. The extreme conditions of space exposing things to this extreme heat and cold cycling of almost 500 degrees every 90 minutes, the ultra high vacuum atomic oxygen and high energy radiation are all things we don't experience on the ground. And then of course that vantage point that I've talked about, and it provides great spatial resolution, and the variable lighting conditions as the sun changes and the clouds change provide some really interesting things for us to see. And I hope I highlight them well as we go through this talk. So the scientific behavior, I gave some examples. We can see here how a flame is on Earth, but in space, it just glows blue because everything's dominated by diffusion rather than convection. Buoyancy is another property that behaves a bit differently in space. And then, of course, sedimentation. All of these forces that are present every day on Earth are completely minimized. The things you drop don't fall straight down. And this is all well and good, but what does this actually apply to for any of us? Well, here are a few experiments that have actually been done in microgravity, in space, the extreme conditions of space. So one is growing plants. We've also looked at hard to wet solids, Alka-Seltzer tabs that you just drop into some water. How do they behave differently? Delta Faucet has looked at how you can use less water and make a person feel more wet by forming different shapes of droplets. Michael J. Fox Foundation studied the LRRK2 protein that's part of Parkinson's. We also have crystallization experiments that relate to various medications for people. We've looked at paint samples and how they degrade over time in the extreme conditions of space and solar cells. We've looked at how radiation affects various materials. We've also used this vantage point of space to look at different parts of the Earth, to launch satellites to do Earth observation. And this benefits many, many industries that are definitely pivotal to many places in the world. Benefits everything from material science and chemistry to earth science and cellular biology, affecting industries like agriculture and raw materials, consumer products, food and beverage, pharmaceuticals, and even energy. But what does this actually mean for Ecuador? Well, It means a lot for you guys. Some of your largest industries are the banana industry, the shrimp industry, and the oil industry. Microgravity relates directly to helping banana industry and the agriculture surrounding it, and helping the oil industry. And I'll highlight some of the work that's already been done in both of these areas. Remote sensing can be applied to everything from banana industry to the shrimp industry to the oil industry. So let's jump in and see how space can help all of us. So why space for the banana industry? How microgravity and remote sensing can help this industry in Ecuador? Well, microgravity allows us to increase our understanding on a lot of things, and not focusing too much on the science here, but we can look at the way plants and microbes interact, something that happens every day on the planet Earth. Can we use microbes as preventatives for plant fungus, ways to treat plant fungus, or other microorganisms as fertilizers, pesticides, fungicides? We can on the ground, so we've looked at it all in space. Plants in space tend to be stressed. They tend to experience have gene expression that's similar to drought tolerance, hypoxia, resistance to salt in water, and weight stress when the fruit on a plant gets too much. Doesn't exist in space, and there's nowhere else we can look at that. It also helps us with indoor farming technologies, methods for watering, nutrient solutions for water, looking at LEDs, temperature control, CO2 removal. And then of course, there's also plant growth, where we have looking at plant seed germination, flowering plants, fruiting plants, weight stress, and root and shoot growth. But really, what does any of this mean? How does it apply to what's going on in Ecuador? Well, one of the ways we can utilize space is in fighting the TR4 fungus. So first, we can study TR4 in microgravity. There are no known fungicides or biocontrol methods terrestrial that have proven effective for fighting this fungus. And looking at current countermeasures, we can start to understand how they can be improved. If we take TR4 to space, we can see, do the spores grow faster? Do they grow larger? Do they persist as long in space in microgravity as they do on the ground? So on the Earth, they tend to persist in the surrounding soil for decades. And we can only destroy it or contain it by destroying all of the infected plants and taking that farm out of production. And then there's a lot of work to make sure that there's no runoff. So how can we bring this to microgravity and use it to look at changes in TR4 that could help us? Well, if we go to space and we look at changes in the fungus as gene expression, it can lead to an effective countermeasure for TR4 potentially, or look at how the current measures that are being tested on the ground affect this in space. But what else can we do in space? Well, work that's already been done on plant microbe interactions. So one of the things that a company named Synergy has looked at is looking at foods like soybeans and peas and beans and other plants that rely on bacteria when they grow in nitrogen depleted soil. So bacteria in microgravity changes the way it behaves. It can become more virulent. We see other physiological changes. So it leads to a change in that plant microbe interaction. And what this really helps us and how we can use this knowledge to help fight something like the TR4 fungus or disease is understanding how changes in bacterial physiology increase that symbiotic nature of plant microbe interactions. How does it increase that positive relationship between these two for agricultural biologics and things like biopesticides and bioinsecticides and biofungicides? And then there's also remote sensing for maintaining plant health. There are a variety of sensors available to monitor soil health, vegetation, and water quality. And the process data could help farmers and industry understand their soil health, their soil moisture content, their vegetation quality, and monitor water quality. And I thought this was a really great example of some remote sensing work that NASA did, looking at the drought in Costa Rica back in 2019. And so what they were looking at, they used something called EcoStress, which is the Ecosystem Spaceborne Thermal Radiometer, that looked at the massive drought in Costa Rica. And what it did is it measured the temperatures of the plants as they were heating up when they were running out of water. So they were really understanding how the drought stress was affecting these plants. And that's just a great real world example of how we use space to help us understand what's going on around us. And if we look to the shrimp industry, we can also use space. What can we use space for in the shrimp industry? Well, currently the shrimp industry has several challenges. Viral, bacterial, and fungal diseases are a big problem in the shrimp farms, lack of aquafeed ingredients for feeding the shrimp, and the environmental impacts of some of these farms bringing in salt water to places that you may not want it. And the future of the industry is looking at improving the genetics of the shrimp lines using traditional breeding techniques and genome editing, and improving the feed for shrimp. So how does space help us with this? Microgravity can help us for the challenges in the shrimp industry because bacteria behaves differently in space. Microorganisms behave differently. And understanding the changes in physiology of these bacteria and other microorganisms that are affecting the health of the shrimp can help us find novel treatments for bacterial and fungal infections. And we can also use these microorganisms for fighting bacterial and fungal infections. Viral infections have become very interesting because we can look at changes in cellular physiology to help us understand the infection mechanism better, and potentially lead us to using antivirals and aquafeed to help us fight these viruses. But we can also use remote sensing to help us in the shrimp industry. We can start looking for bacterial or fungal growth, algal blooms that affect the shrimp. We can look at the environmental impacts. And here we have a picture of the hyperspectral imager for coastal ocean. So this was doing research, HECO, on our coasts to understand how things were changing, progressing, changes in water temperature, changes in seawater levels, so that we can understand what's going on. And we could use something like HECO to look at the shrimp farms and understand if there's some kind of growth in bacteria or fungal growth or algae. We can also use it to look at changes in water and ocean health. Are we seeing saltwater leaching into places where maybe we don't want to see it? And so these are just some of the ways that we could work with the shrimp industry using space. And I think lastly, the oil industry. There's a lot we can do in space with that, and there's already some work that's been done. One of the big problems in the oil industry is biofilms. And biofilms cause microbial influenced corrosion, which causes trillions of dollars in damage and lost revenue annually in the oil and gas industry. And basically these bacteria and other microorganisms form these thick linings that tend to eat through the metal that are the oil and gas pipes. And what's interesting is in microgravity, we see that these biofilms grow thicker. And so using microgravity to determine if we can find new ways to treat these biofilms or this microbial influence corrosion, if we know it works in space, we know it can work on the ground. So really the impact of this is the reduction of damaged oil and gas pipelines, lessening the risks of leaks and spills, and potentially saving billions of dollars in damages. But we can also use the remote sensing of space to look for leaks and spills. So the picture on the right is actually oil moving into the Louisiana coastlines. And you can see this area that's bright blue. The oil leak that occurred was leaching into the wetlands in Louisiana. We can also use remote sensing to monitor greenhouse gases and again for tracking water and ocean health. And I guess it's great that we can do all these things, but who actually gets to use the ISS and how do you get there? And I'm just gonna give you a brief overview, which I'm guessing a lot of people probably already know, but the ISS is a collaboration between the US, Russia, Japan, the European Union, and Canada. It's been continually habitated since November 2000, so 20 years. And the ISS is open for everyone, for research or commercial endeavors. And that's what's really important. There are a lot of ways to get there, but anyone who's interested, there are a lot of us here who are more than willing to help you find a way to do it. So thank you, everyone.
Molly, thank you so much. That was wonderful. That's really great. It's amazing that we have now those tools at our disposal, so universities and students and faculty can definitely take advantage of that and present interesting results that can definitely provide important solutions for Ecuador and the world. And now we'll go next with Dr. Heath Mills. Heath, please, we're eager to listen to your presentation too. Welcome. Okay, he's loading his screen, just be a moment.
Hi, everyone. I have my screen up and on. The presentation too much. And all right, so let me go ahead and get started here. So for today, and I really am glad to hear what Molly had to say, and I thought Molly did an amazing job really explaining and jumping into the why we go to space and why we do this research and how this research can impact and really affect Ecuador as well as the entire world. And so with that said, jump through here. So like Molly was saying a little bit, that humanity is on the move again. We've done it in the past. We've gone out. And in the past, though, the main mode of transportation was confined in one direction, and that was the direction across the oceans. Well, now the sky is no longer our limits. We are in the middle of what is considered to be the space race 2.0. And that space race 2.0 is taking us out beyond the Earth, out really beyond lower and it's the International Space Stations where I'm going to focus the talk today. And rather than going deep into the why, I'm going to explain a little bit about that and really back up a lot of what Molly was saying. But I'm going to go into a lot of the how. How do you get there? What are your capabilities? What are your availabilities? And what's the process like to actually get you to space? Well, so when you look at the International Space Station, the one thing you really have to understand is that the space station is a laboratory. International collaborations are absolutely welcome and encouraged. It is the International Space Station after all. But this is, and from a scientific perspective, a laboratory. And it should be treated that way. This is where we like to come in and try and do ways to help you conduct the research in many of the areas. So to do this and to understand this area from a biological perspective, from a scientific perspective, in order to really harness any environment, whether it's a coastal environment, whether it's a tropical, whether it's a mountainous or an Arctic environment, you have to really understand that environment in which you are doing your research in order to harness that environment's capabilities. And so, again, I'm going to step back and just talk about some of the biological aspects of this. And again, this is reiterating and reinforcing what Molly was just saying. But I want you to think about this. One of the that's how your cells do. That's how your cells make a living. That's how you make a living. That's how you move through your environment. Well, what's been noted over 30, 40 years of good biological research on the International Space Station, and before that, Mir and shuttle and other objects in space, is that metabolic rates change. Biology responds to this environment. This is not an environment that's reproducible on Earth. So why? Why are those metabolic rates changing? Well, let's understand those things. With changes in metabolic rates, you also have changes in pathogenicity. Some cells, some pathogens are more or less pathogenic in space. Why is that? Now you start thinking about research, you start thinking about basic fundamental research, but then you also think about applied research. How can we understand what is happening in this type of environment to help those back on Earth with the modern genetic environment and even biology, you now start understanding that maybe having a growth of different organisms, whether they're bacteria or they're plant species, whether they're shrimp or maybe they're something that produces an oleochemical. If you're able to understand this new environment, maybe you can utilize that environment for your benefit. And so at Rhodium, what we do is we help connect researchers to this new environment. And so we're working on projects right now that are looking at new drug discoveries, utilizing how microbiology changes in this environment. Can you identify new antimicrobials, antifungal, great. What about cells involved in, say, wound healing or stem cells? And then you talk about soil chemistry, biogeochemical cycling. Now you talk about biogeochemical cycling. Think about that. Think about that with the agricultural industry. Molly mentioned the tropical race 4. Absolutely. Can there be a cure for that found in space? Also, the pathogens, the emerging and persistent pathogens within the shrimp aquaculture. Maybe there's a mechanism in space to counter that. Within the plant, algal research. Fundamental research in plant growth, understanding how root systems propagate, how stems rise up towards the light. You can isolate some of these variables in space where you cannot isolate those variables on Earth. Those are amazing discovery-based research projects that are available. Novel utilization of high CO2 levels, water utilization, even down to biofuels and oleochemical production. With changes in metabolic rate, can you identify a way to produce more efficient, more effective biofuels? This is the fun part. This is what we like doing. The coffee industry right now is in an issue right now with climate change, changing the water availability in different areas as climate patterns change. As Molly mentioned before, there's ways to look at crop variants and species variants within space. And then also, in my favorite, I'm a microbiologist. I did a lot of soil microbiology, sediment microbiology. And so utilization of those soil structures, the minerals within the soil, can you look at changes in microbial populations to maybe reduce the effects of fertilizer need or make fertilizers more useful or more efficient? Now you improve land use, directly impacting industry within Ecuador. So you take these different aspects of biological science, and I think it can. Can it be done, and can it be profitable? And we like to throw the little tag on there. If it is done correctly, you can transition these different industries into bring them back. You help those that are back on Earth. So we like to focus here on and do the development side. Let's now take it to the commercial factor, take it to the commercial industry, take it back to the people to help out life here back on Earth. And that happens, those quality results that we are going for only happen with that quality start. So let me introduce Rhodium real quick. Rhodium is a new company in the space industry. We are a commercial space biotech company, and we are here to help serve you, to help get you to space and provide that turnkey solution to space. Rhodium was founded by Olivia Holzhaus back in 2014. We are known for this. We entered the space. We run, working North Grumman and Blue Origin, as well as being on the International Space Station. And this is where I want to get into the how. And like I said, Molly set up really well the why. I wanted to touch on it a little bit, but now I want to get into the details and really show you now. Hopefully you have some ideas about your industry, your research, academic, commercial, and government research. And you're now wanting to, and you're on the edge of your seat, wanting to go to space. So that's our role. That's what we like to do. We want to help you get to this goal. We are an implementation partner for the ISS U.S. National Laboratory. We have the capabilities to partner with you, to work with you, and to move your research to space. And we do that through project development, management, and discuss and explain a little bit about this mission integration and operation line. Throughout, and remember the quality aspect of this, we want to make sure that we add to the project list to produce the results that industry expects. And so that's what we're looking at doing for you. And so let me get into, within this industry, over the last several years, 4 years, we've identified a list of barriers to entry. You're wanting to go, you're wanting to get to space. How do you do that? Well, in this area, what we're looking at is, and what we focus on first, is science. And that science-first strategy. We want to make sure that your project is taken care of from that science-first aspect. Are your objectives met? We put a team of researchers with you to understand your project, planning and operation of that project, protocols, and that quality assurance is maintained. Now, science is only the first step in it. With anything going to space, you sort of need hardware to get there. You need something to put your science into. So Rhodium has developed a set of hardware ourselves. We have a portfolio that we can help integrate your research as it is designed at your laboratory into something that is flight proven, that will get you the scientific results that you're looking for. We're also looking at ways of developing new hardware. So if you're an engineering firm, if you're an engineering university, if you're an engineering company, and you think you have some good design for new hardware, we'd like to work with you to get that hardware flight certified, flight ready, and getting some good scientific results out of that hardware. And then I said I would discuss mission integration and operation. So what this is this is the actual part where your project flies on the International Space Station, where the astronauts manipulate the experiment to get the experiment to work. We, from our Mission Control Center in Houston, Texas, we go through and we help build that project through. We operate it on orbit. We talk with the astronauts, which is a lot of fun to do. And we make sure that the project is done to your standards and to your industry standards so that when it comes back, you have the results that you're expecting to have. Now, there's a quick sequence of events that I'd like to present real fast, and I'm really looking forward to getting to some questions from everybody. With that, and how you would progress through the process to take advantage of this environment that both of us have discussed about today, is we first, step one, going to go talk about the project development. Let's make sure your project is what you think it is and think it needs to be, and then make sure that you have that quality assurance protocols built into place. And we can help also obtain the funding. And obviously, Molly and her company has a great grasp on that funding side. After we've checked those boxes in step one, we go to step two, and we find the first available flight possible. And you can see this kind of bleeds into step three here. Typically, that process goes in about 4 to 6 months. We are moving at the speed of business. We want this project to fly fast. And yes, I did say that we can, project kickoff to flight can be as low as 4 to 6 months. We've done it twice this year. In fact, in this year alone, we've sent 5 different payloads to the International Space Station. 5 different projects working with different teams. Each one of these projects, no project has lasted over 1 year. Each one has been flown in a short amount of time, with 2 of those flown within 3 months of initiation. So you can move at the speed of your industry, at the biotech industry, the drug discovery industry, at the pharmaceutical industry, at the agricultural industry, addressing real world problems. You can do that now. And that is what the fun part is. But as Lao Tzu said, every journey of 1,000, I'm going to roll that up to 1,000,000 miles, because now we're talking about space. But he said a journey of 1,000 miles begins with 1 step. So I ask you out there, who is ready their first step towards the research and development that can help change your industry, change your country, change your life? Because it's fun going and seeing these rockets take off. And we'd be happy to be a part of that process. And Robert, thank you so much for allowing us to do this here today. Thank you for this opportunity. And please, if anyone has any questions after this meeting, after this talk today, my email address, that's my direct email address line on there. I look forward to you reaching out. Looking forward to talking with everybody. Thank you.
Keith, thank you. That was wonderful. Thank you so much for that information. We have quite a few questions, so it's really great to see that the public is very engaged and they want to know more about these opportunities. Let me start with the first one, which is for Molly. Molly, can you share some experience in the International Space Station that has inspired young students to become involved in scientific research?
Mm-hmm. That's a great question. I think one of the most important things that happened is actually there was an experiment several years ago called Genes in Space, and it actually inspired Boeing to spin the company out in its experiment for high school kids to actually go and study changes in gene expression of cells, microorganisms in space. There's also been a lot of work with younger kids, not in high school and middle school, sending seeds to space and growing the plant side by side of seeds from the earth and seeds from space, and trying to understand the changes in the growth pattern of seeds that have experienced microgravity.
Perfect, thank you. We have a great question here for Heath. Are there any plans to expand future ISS, International Space Station installations for more hardware, more modules for research?
Absolutely. There's multiple companies right now that are planning new modules to go onto the ISS, but there's also companies that are planning free-flying craft that will support research autonomously in the low Earth orbit and even out to the moon and in LEO orbit or in lunar orbit. So the number of launch vehicles are increasing. The number of platforms to do research in space is increasing. So yes, it's a great time to start. It's a great time to build. And there's many new opportunities popping up every day.
Perfect, thank you. Molly, I have a question. What about opportunities for publications and participating in conferences? Is this something that there's a room for research to be presented if university students and professors in Ecuador are going to be involved? Where can they show their work?
So it's a great question, because there are a lot of conferences and they're only growing in size. They're not necessarily huge right now, but one that's very popular is the International Space Station Research and Development Conference. It's growing every year. There's also the the IAC, the International Astronomical Conference or Astronomers Conference. I can never remember the name of it, but that's an international conference that moves around the world that people can attend to present their research and to talk to other people in the industry. Same with the ISS Research and Development Conference. But I also highly recommend going and presenting your work at conferences in your own field. Tell other people about what you're doing. The ISS is open and we need more researchers going there so that we can get more modules and have more equipment on the ISS.
Perfect. Heath, what about in a close future, what about this technology? Do you think it will be available for countries like Ecuador to participate? Based on your presentation, you said that you're ready to help and provide assistance, but how can we view that? Is that something that's accessible right now?
Absolutely, it's accessible right now. We have worked with, Rodian has worked with other foreign countries before. through partnerships and through the International Space Station, ISS National Laboratory, we can fly projects tomorrow. Actually, we're going to a launch here in a couple weeks to support some projects. So yes, it is available. Start now and start connecting in, and yes, we can do that now.
Mhm.
Perfect. Molly, what about international collaboration with other universities? How easy is this topic to get other people excited to participate and work in tandem?
It's very easy. There are the handful of researchers in the US who are just always looking for someone else to collaborate with. And I'm sure there are a lot of researchers in Ecuador and around the world who don't have experience in space. So that's the kind of thing I'm happy to introduce people to researchers who are already doing this here in the US. And the only reason I say the US is because we're the only country that has something like the ISS National Lab, and it just makes it faster and easier to get to the International Space Station if you partner with a US university who already has access through the ISS National Lab.
Okay, perfect. Heath, one question for you. What about the universities right now and research centers, for example, in Ecuador? They currently have their own facilities, their own technology. Do they have to do any major upgrades if they're going to be doing this type of work, or can they exist and leverage their existing infrastructure? How does that work in regards to that?
Everything ever required to work in the International Space Station. The key with that, like Mike said, is to partner with the right groups in the U.S. We can either be that partner or we can link up the right groups together. So the key here is to identify the right partners to be able to move forward. But I would, like I said, I would not anticipate any major upgrades that would be necessary. Right now, it is open for commercial use for institutes to use, and we can help you get on that process and get onto a vehicle in a very short amount of time. So we're ready to go.
Perfect. Molly, do you think that all this data that is going to be generated, as part of the scientific process, does this allow for having multidisciplinary teams to be involved and be collaborating, not only certain type of researchers under a certain type of profile, but having a wider role within the universities to participate in these evaluations and opportunities?
It's a great question. And yes, it does really lend itself well to interdisciplinary research teams. And one great example of that is anything to do with remote sensing. A lot of those sensors, and I showed pictures that are on the ISS, the data is publicly available from NASA, from the European Space Agency, from the Japanese Space Agency. You really just have to ask. So if a team is developing a sensor and they want to do the data and they want to have someone so we have someone in aerospace developing a sensor and someone in computer science doing the data processing, they can already start working on those algorithms ahead of time because there's publicly available data. So the team knows they're ready to go once they get everything in space, that the algorithms are working. They're able to do various technical readiness level tests before they get to space so that they know that their sensor is going to be working. And you can bring in anyone. You could bring in mathematicians, you could bring in biologists who understand, looking at those pictures, what the changes in the coastline are. So it's a really great opportunity to bring together big multidisciplinary teams and go after some big grants and really trying to bring people together and maybe even spin a startup out of it.
Oh, that's an interesting aspect about entrepreneurs and how they can get involved in finding those spaces within the economy that need certain attention. Heath, you mentioned that you were a new company that started a couple years ago as an entrepreneur with Olivia, the founder. What are you seeing now in new companies that are looking to be involved in space? Do you see that as a new important aspect of the clients that are interested in space, or are more traditional companies? Who's getting more involved?
So to develop new hardware, new data sets, and you start building that ecosystem within the space environment. So the more companies that get in, the more access is available, the more funding sources start moving into this area, and the more success they realize into the whole industry. So our company was new. Our company was new a few years ago. We've seen that progression coming through. And so that's where we're trying to now encourage new partnerships, new collaborations, new startups to get involved. And with their success breeds more success. With new access to space coming on daily, this market is only growing. That infrastructure will increase. And countries like Ecuador have a great opportunity right now to get into and mature into this environment where everybody right now is learning a new field. And so it is helpful to get these new companies involved. And I highly encourage the entrepreneurs out there to get involved and start doing this.
Perfect. That's great news. Here in Ecuador is very famous because of entrepreneur spirit. So this definitely can be a great tool for people to consider in following those career opportunities and challenges towards that economic development that we want to see for the country. Molly, when we start thinking about international collaboration, how do you see the role of governments in supporting this type of research and tools? Because we see that the United States has a lot of tools available. The Europeans also have a lot of tools available, and we see some encouragement that they have and support. For example, in Ecuador, there's many type of agreements with this international community, and sometimes that's directed to different causes, social issues, other types of support, but nobody really talks about maybe on the research side of the funding that could be available. Is that something that you think that can bring countries together in that aspect, in having those relationships with the European Union and in this case, United States?
Definitely. I mean, I think the biggest example of this is the International Space Station, where 5 different space agencies have come together to build the only 20-year-old orbiting habitat in space. But beyond that, government sponsoring research, there are examples of cross-governmental work. The government of the state of Florida and the nation of Israel have a grant every year called the Florida Israel Grant, where Israeli and Florida companies work together. And there are companies in Israel that have then opened companies in Florida. Having governments sponsor these kinds of things, again, as I talked about, to benefit the local industry, and working with other countries that maybe they're more advanced in the space industry and Ecuador is more advanced in the agriculture industry, or vice versa. When Ecuador becomes experienced in space, you partner with another country that's more experienced somewhere else, lending a hand to bring everyone together and improve everyone's technologies and capabilities in multiple fields at the same time while using space to benefit it will only help all of us and only encourage more collaboration. And whether it's a future international space station or it's some kind of free flyer for research, giving people access just allows all of us to grow.
Thank you, Molly. Heath, one question for you. When we're looking in this case at all these different industries that are big opportunities, and we see the university role, do you think the university has an important door to knock in this case, to reach out to the business sector and tell them, hey, we can definitely do some important job for you in doing this research to find those solutions to your biggest challenges. And now we can use space as an important tool for that. How can they go about it and explain that message, especially for companies that are not involved in the space sector, like a traditional agricultural company? You know, that type of conversation sometimes can be a challenge, but selling the idea about the benefits and what's available, I think, can be a winner. What would be the right way to do it, in your opinion?
Well, first off, can academic environment be a door opener? Is, I think, where you started the question. And from my background, I was an academic professor at 2 universities and conducted research in extreme environments. I feel that academia is the Kickstarter for many new research projects. And so with academia being that foundation for knowledge, that foundation, this is where you're not only training the new workforce, and that's what is traditionally being seen, but now you should look at technology transfer. You should look at and write publications, write papers, write grants, but also write patents and write the business plans that will spin off from the university, either with the students or with the faculty or with support of the university itself, to start going into these new fields. The universities have the capacity to take a greater risk than some commercial markets. They have the manpower, they have the resources, they have the intellectual capacity to jump into these markets and really be transformative. And I think that business can take a look into and start farming the universities and some of the ideas that are coming out of those universities, not just the students, but new technologies, the new data sets, the new ideas, the new initiatives, and use those as catalyst points to increase the entrepreneurial success within the economy and the commercial industry sector. So look at academia for ideas, look at academia for students, look at idea for business spin-ups, because within that idea and that drive that makes an academic environment, that willingness to take a challenge and go and push further, that's what they're there for. And that's what they do better than anything else. And so academia needs to lead this new forefront with government support through grant writing, through grant opportunities. You can really kickstart the universities, and even STEM education cannot be overlooked. When you get into the upper levels of the secondary education structure, those students can be started and engaged in space. Many of those students have been alive. They've been alive the entire time the International Space Station's been there. They know space. They expect space. They want to work in space. Give them the tools to keep them in the space industry and watch what will happen. That's what I'm excited about, and especially these new academia.
I lost you there for a second, Heath. Okay. Well, this has been wonderful, amazing, the amount of information, Molly and Heath. Thank you so much. We really hope that this has been very beneficial for all the faculty at UTPL and for all their students. So they can definitely consider these great sources and avenues for them to look into the future about how they can propel their entrepreneurship spirit, how they can definitely excel at research and finding those solutions for the primary sectors in the economy of Ecuador. And we definitely see that linkage, and we definitely want to thank you for your friendship and help in sharing your time today. Thank you so much. And I'm going to cede now the words to Gabriela. Thank you very much, Gabriela.
Thank you, Robert. You did good as moderator today. And thank you to our two wonderful speakers, Molly Mulligan and Heath Mills. You were amazing. And all the people that saw you were really happy to know everything about this really important topic. Thank you, everyone. Thank you to all the people that follow us on our live transmission. We were really honored with your presence. So this is the way we finish this webinar with this important topic, using access of the International Space Station to promote research and productivity in Ecuador. It was a pleasure to have you all of you people here, and hope to see you again. Thank you very much and have a great night.
Nunca tuviste sueños pequeños. Nosotros tampoco. Por eso, tienes una universidad que, al igual que tú, no tiene barreras. Y eso nos ha llevado a ser la número 1 en el país en investigación, tecnología y relevancia según el ranking Web of Universities. Uno de los más importantes a nivel mundial. Cuando tú lo haces en grande, nosotros también. Inscríbete en la UTPL y estudia en grande. UTPL. Hagámoslo en grande. Elegir lo nuestro es ayudar a nuestro país. Pero no solamente hablamos de preferir lo que está hecho en nuestra tierra. Hablamos de una gran riqueza intangible en crecimiento. La educación y sus talentos, que entienden qué es lo que le hace falta al país, nuestro país. Esa es la razón por la que la UTPL desarrolla proyectos que cambien nuestra realidad, preserven nuestra riqueza, patrimonio y diversidad. Creamos e invertimos en las ideas que están cambiando nuestra industria y la ayudan a crear y creer en un Ecuador de muchas oportunidades. Por eso, cuando vayas a elegir una carrera, elige a la UTPL, una universidad orgullosamente ecuatoriana. UTPL. Desde Ecuador, lo hacemos en grande.